Have you ever clicked on an icon and just wondered how it all works? Like, how does this box of metal and plastic instantly know what to do? Well, that magic, that thinking, it all happens in one place. Today, we're diving into the brain of your computer, the CPU.
I mean, it's a process we totally take for granted, right? You type, you click, you play a game, and the machine just gets it. It understands. But how? How does a computer actually think? That's the exact question we're going to break down right now.
Well, the answer is a little thing called the Central Processing Unit, or CPU for short. And calling it the brain isn't just some catchy nickname. It's honestly the most accurate way to describe what it does, because it's the command center for literally every single thing your computer does.
Just think about it. Our brains process thoughts, they make decisions, they do math. Well, the CPU does the exact same thing just for your computer. When you're editing a video or even just wiggling your mouse across the screen, it's the CPU making all those tiny decisions and calculations at an unbelievable speed.
Okay, so just like our own brains have different parts for different jobs, a CPU isn't just one big blob of silicon. Nope, it's more like a highly specialized team, a little crew working together perfectly. So let's go ahead and meet the key players on this team. All right, first up on the roster, you've got the control unit, or CU. Think of this as the director, or maybe the project manager of the whole operation. It's not actually crunching the numbers itself. Instead, it's reading your commands and telling all the other parts what to do, when to do it, and in what order. It's the boss. Next up is the Arithmetic and Logic Unit, or the ALU. Now, this is the math genius of the team. It handles all the heavy-duty number crunching, adding, subtracting, you name it. But it also handles logic. When your game needs to check if you have enough points to level up. Yep, that's the ALU making that logical call. And finally, we have registers. The best way to think about these is to imagine you're cooking. Instead of running to the pantry every time you need a pinch of salt, you have a little bowl of it right there on the counter. That's what registers are. Tiny, incredibly fast little memory spots right inside the CPU, holding the exact data and needs of that very moment. So, we've met the team. We've got the director, the math whiz, and their high-speed notepads. But how do they actually work together? It all boils down to this really simple but incredibly fast three-step process that the CPU repeats for every single command. Let's make this super concrete. We're going to follow one simple instruction on its journey through the CPU, 5 plus 3. For us, the answer is instant, but for the CPU, it's a very carefully executed three-part process. Okay, step 1, fetch. The director, the control unit, goes and grabs the instruction 5 plus 3 from the computer's memory. Step 2, decode. The control unit looks at it and figures out what it means. It's like, aha, this is an addition problem. I know who to call for this. And finally, step 3, execute. It passes the job to the ALU, which does the calculation and gets the answer. 8, fetch, decode, execute. That's the whole cycle. Now, here's where it gets absolutely mind-blowing. That simple three-step cycle we just walked through, it's not happening once or twice. It's happening billions of times, every single second. It's this endless, lightning-fast dance that powers everything you do on your computer. Now, you've probably seen terms like gigahertz or quad-core whenever you're looking at a new computer. What in the world do those actually mean? Well, they're the key stats that tell us just how fast this brain can actually think. It pretty much comes down to three big things. First, you've got clock speed. That's just how many of those fetch, decode, execute cycles can happen per second. Then you've got the number of cores, which is like having multiple brains working on tasks all at once. And finally, there's cache, which is a small, super fast memory that keeps frequently used data close by. To put that clock speed into perspective, if you see a CPU is rated at 3.5 gigahertz, that means it can perform that three-step cycle 3.5 billion times a second. That's a number so huge, it's kind of hard to even wrap your head around it. And what about cores? Well, that's all about multitasking. A single-core CPU is like one person trying to juggle multiple tasks. A quad-core CPU, on the other hand, is like having 4 people working in parallel. That's why you can have a video call running, a browser with 20 tabs open, and a game all at the same time. You've probably also heard of a GPU, or graphics processing unit. Think of it this way. The CPU is like a master chef who can cook any complex dish you ask for, perfectly. The GPU is like a pastry chef who can make thousands of identical cupcakes all at once. The CPU is a powerful generalist. The GPU is a highly focused specialist. built for rendering graphics. So why does all of this matter? What's the big takeaway? Because at the end of the day, the CPU is the single most important factor in how fast your computer feels. It's the engine that drives everything. From the moment you turn your computer on, the CPU is in charge. It runs your operating system, it executes every piece of software, and it dictates the overall speed of your experience. Without a good CPU, your computer is just a box of parts. And here's the real bottom line. You can have all the RAM and storage in the world, but if your CPU is slow, your entire computer is going to feel slow. The brain sets the pace for everything. And that brings us to the future. Every year, these computer brains get exponentially more powerful. The phone in your pocket has way more processing power than the supercomputers that sent humanity to the moon. So as this incredible evolution continues, you have to wonder, what's next? What new worlds will these ever more powerful brains unlock for us?